Yeah. So I'm going to cover some principles of data management, how to develop the CRF, and what are the basic critical data management practices which we use using some softwares. So we all know how the data is going to flow, right? So we start with the data comes from the from the patients. As an investigator, you start collecting the data based on your protocol, and you use all kinds of data coming from all places. Like you have laboratory data, you may have your research data, you may use the patient data, everything you collated together. Then you kind of goes for monitoring, sometimes you clarification, data clarification, you resolve it, and then you use a whole lot of iterative process. And then the data manager manages the entire data and report to statistician, and then you analyze, and then if it's a blood trial, you supplement it to your regulatory authority. But what happens here is most of the times we do it as a single person, right? You may be doing all the jobs, but if you have a team who can help you, you can see what role to assign for the team members. Now, what is clinical data management? It is a process of collecting and managing research data in accordance with regulatory standards. The objective of CDM is to provide high quality data by minimizing the errors, and also you gather maximum data for the analysis. So maximum doesn't mean what all is possible you're going to collect, you'll see what to collect. Now the purpose of CDM, that's clinical data management, is you have to collect, it helps you to collect relevant data in a specific format. And also we have to keep in mind it should be in accordance with the protocol. It's not a general patient data which you're collecting. Always keep in mind what is required or what is being mentioned in the protocol as what you'll be collecting only should be collected. Okay. So compliance with regulatory requirements, it allows for efficient and complete data processing, analysis, and reporting. You have a good data management built in along with your protocol. It will be easy for you to analyze your data at the end. It also facilitates the exchange of data across projects and organizations, especially you have a standardized way of data transfer. Like if you are collecting data from different sites, so it will be good if you have a proper CDM, then you can share it across the sites and make sure that uniform data is collected from the sites. Now, you all must be aware of this, regulatory requirement for the data management. It's called FDA Readiness CFR Part 11. All that it says is you should have this requirement, these are mandatory requirements for the compliance of 21 CFR Part 11. It says you have your computer system should be validated, that you should have a robust audit trail. I believe what audit trail is. You should have a security access controls. You cannot, anybody cannot be accessing the data. You should have a kind of security access controls. You have to specify the design, system design you're doing, and what are the NHS. You have to have a mechanism for archival procedure, where you keep the data, how you respond the data, all that. Of course, lastly, the electronic signature is mandated in your 21 CFR. But we may not be following the investigative trials, most of the steps, but you should be aware of this regulatory track. So, what are the principles which we need to follow when we do proper data management? And we can use this ALCOA principle. It mainly talks about your data quality. Okay? So, data quality, you should be very careful in whatever data you collect. Small piece of this information which you're collecting, it should have a proper value of the data you're collecting. So you follow this principle. One, it should be accurate, it should be legible, it should be complete and contemporaneous, it should be original, and it should be attributable to the person who generated the data. So what are these? What is the accurate? So whatever the trial data you collect, it should capture the source data. Whatever you put as a source data, what is source data? That is a patient file or an electronic medical record which you may be having in your hospital for routine data collection. So it should accurately capture the data. It should not be like, in the source file something is written, but in your CRF something else is going to be. So you have to make sure that it is accurately documented. Any corrections or changes are documented, right? So, and it should also have an audit trail. So audit trail means what? You should be able to document the changes which happens to the data. Like who has entered the data, when was it entered, what is entered in your data, why if there are any changes, why there is a change, what is old value, what is new value, I'm sure the kind of data which you're managing using Excel or SQL doesn't have any of these features. So you can freely, or your team can freely keep changing the data. Nobody is going to check because there is no source document verification done in our routine data management, right? We don't have any data management at all happening in our data, right? So now, the second principle is called legibility, right? You should have a clear handwriting on the CRF. You should not be scribbling, and you should be neatly written. And do not obligate information with making changes or corrections. Whenever you make a change, swipe it or write the new value, sign it properly against it, so that you are taking the responsibility as an investigator that this data has been changed and I'm aware of it. Right? All that. So all data, including metadata and audit trails, must be in human readable form. Many of us may have the habit of write much nowadays, right? So we will have a habit of scribbling the data, having to say something about the CRF, which will be kind of misunderstood and something else will be entered in the database. Now, the data quality should also be complete and contemporaneous. So, what is this? Avoid blank data fields or provide explanation why it is blank. Whether it is not done, a test is not done, the data is not applicable in that case, whatever name, unknown, unapplicable, not applicable. Please specify clearly so that we can take care of the analysis. Leaving a data blank means many things. We don't know, right? So we have to be very clearly specifying that. We record the result, measurement, or data at the time the work is performed. That is called contemporaneous. So something has happened. For example, an adverse event has happened. You record it late and you kind of report it late. Is it acceptable? No. So you have to be kind of recording the result, record of the measurement of the data, the time the work is performed. And audit trails to provide evidence of timing. So audit trail will give you all this information. Okay. And of course, data has to be original. In whatever the lab reports, your questionnaire data, everything has to be original. Accurate transcriptions of source data from the source document is important. The last principle, which is attributable, who recorded the information. You should designate the staff who will be kind of entering the data. You should have a log. Who will be responsible for what, who will oversee the data management, who will be entering the data, and finally, what will the investigator do looking at the data. All that has to be mentioned. And again, you have to have an audit trail. So, with all this, you kind of move forward to create a CRF. What is CRF now? It's called case report form. Okay, so a case report form or CRF, it's a document designed and consistent with protocol. To record data and other information on each trial subject. So it's not that, okay, I want to collect all this information because I got a chance to collect. It's not like that, right? So you should be very careful what has been mentioned in the protocol, what are your objectives, what are information you need to collect in order to address your objective without leaving even your tertiary or explanatory, right? So a CRF should have all of the things which are required to answer your research question. So now the CRF can be in the paper form or in the electronic or in the remote data capture form. So I would say, though, if you're starting, if you're a new investigator, take the experience of designing a nice paper CRF so that you know what to collect and how you will be collecting, and start recording all the information on paper, right? And then kind of put it on an electronic data capture form. Okay, so that is the way you should go. But at times you will see some sponsored trial directly you have an electronic CRF and you will start entering the data. Now, how big a CRF? It depends. It depends on what is your proposal case. So accordingly, you may have 2 pieces of paper with all the CRF, or you may have a booklet. If you have a book, means that you will have repeat visits of data collected and so many follow-ups are there. So you have to put everything in the CRF and it becomes collected. So when you're collecting lab data, suppose you're looking at biomarkers and everything, it is often not a part of your CRF. You will know that part of the information I manage in some, part I will keep in some. So don't do that. Whatever required for your research project, have it in one place. So that is very important. Now, CRF is generally coming from protocol. So you have to translate your protocol to CRF. So you will be very careful. So protocol determines what data should be collected on the CRF. You have to kind of collect all the data that is required for the protocol. And data that will not be analyzed should not appear on the CRF. What is required to be analyzed only should come on the CRF. And CRFs are only as good as they design. In the sense, if you have a unclear site personnel who doesn't know what to collect and how to enter, then your data will not be accurate. Okay? At the same time, you may have data entry operators who's doing the job without knowing what needs to be entered, and you could kind of enter it, then also the data will not be accurate, right from capturing the data as well as entering the data. Okay? So if it is not reflective of the protocol, I mean the protocol says something and some of your CRF is not capturing it, then also it's of no use, right? So you have to keep in mind, somebody is going to enter the data, whether that person is kind of aware of all the terms, help them to kind of do a mock data and train them, all those things are required. And finally, it should be easy to use. Okay, so that is all about CRF. And if you see the development, how do you go about? There are some guidelines how to develop the CRF. You collect data outlined in the protocol. So it should follow logical order. Right? You should know, okay, I'm going to begin the study. What is the information I'm going to collect at the beginning of the study? Next what? There should be some kind of logical order. I'll show you an example of one study developed in DMH, so that will give you an idea. And you should be clear and concise with your data questions. What is that you want to avoid duplication? You should not be repeatedly collecting the same data or same patient again and again. And keep free text responses very many. I know all of us have a corner for comments, remarks, so that anything unclassifiable, let me put it so that it is there in one place. Later on, I'll see what will be done. I'll give you some examples how it has been kind of coming to us, and we have to kind of code it based on this thing. It becomes very difficult for us. Okay, try and see you can minimize the text fields. I'm not saying you should not have it. It is required because remarks also gives you a lot of information. But try and see if you can minimize. You should not be having for often remarks. At least speak for what is required. And collect data required by the regulatory agencies. Provide units whenever you collect data, whatever be the lab data that you're collecting. You may know the unit, but doesn't mean that you should not be doing it. What will happen is sometimes you may have to converting units into the required. Some other center will give you data in one unit, and you have to kind of translate it to your listing. It becomes very difficult. If you don't have a unit, then it's going to be very difficult. And you should provide instructions to reduce misinterpretation. When and where possible, you give that. I'm showing an example. Provide choices for each question, options. So if you feel that you can kind of categorize the responses or what you see, give it. If you know beforehand, start giving the options and have one as others. Suppose you feel that beyond these three options, we'll have one more, give a other and give a blank receipt. So if you feel something happening very commonly in others, then you can put the data into one of the categories. Allows for computer summarization to be easy. And please make sure to differentiate and use no and not that. They mean different things. A response is no and response is not that means different, right? So what happens is no sometimes is being entered as not done and not done is sometimes entered as no. It's not the same. Not then we don't know whether it's going to be yes or no. But no is definitely a no. So be clear about it. Use it, but know how to differentiate that. Now, modules collected at multiple visits because we are not collecting one-time data, right? We may collect repeat data, right? It could be a lab data, it could be a follow-up data, it could be anything which you're collecting at every visit, right? So you should have separate modules for it. Toxicity, like QL data you will be collecting. So repeat visits, how to collect, how to store, all that will be very clear. Don't collect fields that can be derived, right? Don't collect that. If you are looking at age, don't collect age if you have a date of birth. Okay, so in that way you should be the same. BMI, why you want to collect BMI when you have height and weight, you can always calculate it. So duration, you don't have to have a duration variable because you're bound to make mistakes. Either stick to the date and then calculate duration or don't ask for it, right? And you don't have a non-repeating question and a bit of repeating questions. You have a repeating question. Suddenly bringing in a non-repeating question, it will be very difficult for someone to kind of, the flow is disturbed. So don't do that. Okay. And if you're translating the CRF into different languages, okay, you have to ensure that there is a consistent meaning in all the languages, like how you transform and translate. Similarly, if you're collecting your data using multiple languages, make sure it is collecting the same data. The meaning has to be same. Now, how do you develop this CRF? It's a teamwork. It's not a single because you're working with multi-speciality this thing. So you should always keep everybody together if you're developing the CRF. So like sometimes you may have to collect pathology information, sometimes you may have to collect from the radiology or medicine oncology. You may be aware of it, but still you should always involve them like a board investigator in the research project. At least involve them so their inputs also will be useful while you're designing. So who all can be a team for developing CRF? You have a principal investigator, 4 investigators can be a part of this thing, and there's a clinical data manager who tells something, this is how we need to kind of develop, and a statistician, there will be a programmer or IT expert, and there will be a data entry operator. This is exactly what we followed when we developed a registry database and a DBT project, which I will show. So use a draft protocol to design your CRF. There are some standard modules. Like for if you're working in a hospital, your hospitals can have DMG, disease management group. They will have a standard data collector, right? So at least follow them because you've already put time and thought, and then they have to use that standard modules. And then additionally, you may have your disease related or treatment related, whatever you collect for your research project. So the best way to start is, how do you start? Okay, you're aware of these are the things we should keep in mind. How do we start it? You start with a simple pro forma. Pro forma will just list what all variables or data you need to collect. It may not have an order, but start putting down all the information. Right? So then start expanding, then start organizing, and then develop the CRF. If you're a new person, that is how you should look at it. Now, how do we capture data? We are irrespective of what phase of study you are, phase 1, phase 2, whatever be, you have to kind of collect data in a proper fashion. So you can have it, as I said before, a paper-based or an electronic-based or a remote data capture. So, should I do paper-based CRF and as well as electronic CRF? The choice is yours, but I would say that there are differences between the paper CRF and CRF. Okay, the time for the data entry is more. I know because you have to capture all the data from the source document. It's going to take a lot of time. There is an electronic CRF, same data, you can collect it in less time. Discrepancies generally are more in paper CRF, and in electronic CRF we have less discrepancy because we build in checks. As and when the data is entered, we build in checks. And query resolution is slow. First of all, a query raising itself is not very in paper CRF. Right? But here you can raise a query, clarify it, and resolve it also in electronic CRF. Time to complete and analyze is more, and there is less. Chances of error is very high in paper CRF, where it is low. Accuracy, of course, is very high in electronic CRF. And the data management is tedious because you need to have a lot of people and keeping records here and there. Suddenly you see one file missing, one visits of all the patients' QRS missing. It is there on this thing, but it is not there. It's very difficult because multiple, you have coordinators, you need handling the data, they have to come with the patient, they have to transcribe the data, somebody else will be there at the research fellow, there will be SR or JR, handling. Same people will be doing all the same project. But it is going to be very difficult to put in a paper CRF. Now, I will take you through an example of how the CRF is to be developed. Now, the first thing when we start developing a proper CRF, we start with the header. Right? So, header, what we do is we kind of give this protocol, cycle for ID, center of site code, subject ID, and patient initials. This header will be repeating information in every page of your CRF. Because it will be easy for you to track, who the patient, whose data is entered, and which center it is, and all that you can track very easily. A footer is given very small. What you can have is for your purpose. You have a short title of your project. Okay, you have version of the listing because CRFs will undergo a lot of versions. In designing while designing your CRF, put the version number and put the date. It was the last version finalized. And also in the footer, please mention your page numbers. Don't put 1, 2, 3. Use 1 of 2 or 1 of 3. So you know the total 3 pages are there, and if anything is missing, at least you'll be aware of it. Now, this will be there for every page, and then Why this is important is when you're linking between the related pages, it is easy for you to track it. That is easy. Now moving on to the actual contents of the CRF. So what all should be there? I mean, I'm just giving you an idea. If you're doing a randomized trial, you have a randomization form, you have a baseline data collected, you have the pathology data, you have the treatment-related information, toxicity information, and then you may have some lab data coming in, site-specific, and then you have the follow-up data. This is something broad. You may add depending on what your project demands, right? So I will take you through each of this. This is a study I was mentioning. This is done in Cambridge, and Breast DMG has conducted this thing, and they have nicely made a CRF. Investigative initiative study. They have made sure that it is on par with the regulatory requirements and requirements. Okay, this is a paper CRF. So if you see, the 2-page randomization form is there. You see there, it's blurred, but I can explain. The first part is your identifier, which is on the header always. Then you have an eligibility checklist. Each criteria should be kind of recorded as yes or no. It's not that you kind of put one box. You put 2 boxes, and all these things will be filled up. Finally, what is the treatment assigned? Okay, so this is how the randomization is done. Still, some of the studies, this has to be filled and brought, then the central CRS does the randomization. Okay, this is the form. Although it looks meaningless, but it should be a part of your CRF. Okay, so when an audit or anything comes, so you have it in place. So next part is your this thing, baseline data form, right? So baseline data, again, if you see the headers is coming up, and you have all the this thing, and of course there's another form, demographics, which is not there, but it should have all the patient data, all that, their age, gender, all those things should be having. And then this contains the pathology, this contains the amount of biochemistry data, and some physical examination. And there are 2 sheets of the baseline form. So everywhere, whatever the visit type, date, what visit is it, date has to be captured, what is the data you're capturing, everything. And at at the end of each instrument or the CRF, you see this, it should be signed and dated. It's very important. So whoever is entering the CRF takes the responsibility of that data, right? So, and this is another form. This is called histopad. And if you see there, they've given nice instruction that complete the form after surgery and histopad report is available. Because you will get incomplete data and you start filling it and then say no data available after. So make sure that you follow the instructions as to when to enter the data. Okay, so if you are training your data entry operators or your trial coordinators to manage the data, you have to run through the first few data which you are entering with them, explain them clearly, and they have to follow the instructions. And then sometimes your data can be in a single option form or in multiple options. So if you're saying single option, please mention it in your data itself. Say that select one option. So if it is specified, whoever is capturing that information knows that it has to be only a single option. So multiple options are there, so you can see, you can select all that apply. You give the condition in your CRF itself. So we know that here multiple options are allowed. So basically what they do here is they pick the data. That's it. Every box will have a tick. Right? And like you can, that's how it is. And finally, it is going to be kind of signed. And you see there, there's one this thing which I've highlighted, that the ER status and PR status. Negative, positive, unknown, and not done. I mean, there are some patients information is not known, and some not done. If you don't take it, specifically this was brought in the CRF so that it's not kind of entered as missing data. As I said, missingness may be unknown or missingness is not done also, right? So you have to clarify. That's the reason they have added that also in the CRF. Okay, and finally it has to be stated in the sign. And this is a follow-up form. Okay, this follow-up form captures all the information: what is the status of the patient, follow-up date, when did they come to the follow-up, and what is it. And additionally, they for the performance status also, because probably they want to assess the performance status at every follow-up, and then death, if there's a death, or if the patient is alive. All those things should be recorded in this, and there will be a repeat instrument. Follow-up will be every time the patient is coming, whatever follow-up interval, it has to be recorded. Now, we have created a nice paper here. We have learned how to do the whatever sections and everything. The next part is data coding. From CRF to coding the data. There are some commonly used data types for which how to code I'm showing here. Typically, like data which will have date, which will have a binary information, which will have some categories in code, or it might be a continuous data, so numeric data, and it should be a free text. These are some 4-5 distinct types of data which should be collected. Suppose you have a binary data, you code them yes, no, yes, 0, and 1. Maintain the same form in all through your CRF. Each other page is 1, 2 is yes and no. In another place it's 0, 1. Try avoid all these things, because when you analyze repeatedly, if it comes to if you know that 1 is yes and in the other type of variable 2 is yes and 1 is no, so we are continuously analyzing, we will misinterpret the data, right? When you have a consistent way of coding your binary data yes and no. And for categories, you can have it in this way, right? And at least if there's an ordinal variable, start ordering the kind of values which you assign. Or if you are independent or distinct categories, you can give whatever 1, 2, 3, 4, 5. That is your wish. And then important is the date variable. How you define your date. You are defining it as day, month, year, or month, day, year. You have to be very clear. Okay, and you select what format you want, so that that particular variable will have the same format for all the patients. Okay, that is this thing. So we learned what are the variables, different types of variables, how to code it, and then we will start entering the data. Now, data entry is usually kind of done by data entry operators or by coordinators, researchers or fellows, GRS, any one of these people, right? What is bothering us is your data entry operator. Trial coordinators sometimes will be familiar because it goes work with the team, but data entry operators, they should be clearly kind of given CRF with all the values entered. If you ask them to infer some data, they will not be able to. They cannot. So whenever you're capturing from source data to CRF, don't leave the job to a data entry operator, although he or she may be trained well, but it has to be done under the supervision. Okay. So that is one thing. We have to kind of whether to have a data entry manual or not, I leave it to your choice, because some cases they have a data entry manual. So this variable, what you should be entering, where you should be seeing the data. Like that, you can have a data entry manual also. And you can train the data entry operators. So it is at least in the beginning, train them, allow them to enter some dummy data, check as an investigator whether it is okay, correctly enter and all. And then you finalize the data entry, right? So the flow is like this. You have a source document or a patient file, your hospital EMR, or a patient diary, all this. From there, you are transferring to a paper CRF. From there, it goes to, it's paper, it's an eCRF, and then it moves to the analysis part. That is, it is getting exported to any statistical software like this R or SAT. So you have to be very careful in kind of entering the data, because whatever this thing goes in will go in for the analysis also. So
can I go directly from paper CRF?
Generally, I said by electronic means you may have an Excel sometimes, you may have some other access, or it could be some other software also, and from there it goes to analysis. Okay. So it's always good to have a nice database management software. So what is the role of DBMS? You define a data dictionary, you tell what type of variable, what range it will have, everything you define. And then how each variable are interrelated, you can give some branching logics, you can give some conditions while you're entering the data and all that. And it helps in centralized collection of data. I mean, you don't have to be there physically present wherever the data is being collected, it can be done centrally. Querying and DCFs are easy when you have a DBMS. Okay, you may be sitting in one main center and you have 4 or 5 centers. You can't be physically be present or go there and check what other centers are entering, right? So if you have a good database management system, you can avoid all these things and then you can have a central data management procedure. Yeah. The query resolution is easy, it will ensure data integrity, it will also be kind of allow security and multiple access to the data. So commonly used data assigning or analysis software are, you use spreadsheet. It's free, but I would say it is not a database management software or it's convenient to use, right? But please don't rely on it fully. Okay. So it is not HIPAA regulated or it is not 21 CFR compliance is not there. And work group capable database management softwares are there, like MS Access you can use. These are other visual software. All these things are available. If you know how to kind of use it, it's fine. And when you're using multiple centers or data center multiple studies, you can go for an enterprise RDBMS systems, which is like Oracle or MS SQL Server and all those things are good. And softwares for analysis, these are the dedicated ones. Okay. So now, and finally, you should have a good confidentiality and security in your data, right? So to protect that database, you should have a secure server, okay, and it should have a firewall, and it should have access restriction, and you should be able to trace it. Login passwords, different rights, who will read, who will add or delete, who will change, all that. The loss of database should be prevented. You should take regular backup of your data and offsite storage. You archive of copies, future use. Finally, you have to audit the copy of it. Last, it's your data log. You keep on entering the data. Today you're going to analyze, tomorrow you're going to you finish the data, and tomorrow you're about to submit your manuscript, and today you got one more patient data. You're going to update it? No, you're not going to do that with them. You have to have a cutoff time for working your data, beyond which you're not going to, even if you get an event the next day, you should not be adding. So that is called a cutoff date. You have to always say that this is the cutoff date for my analysis. Okay, you can block that. Right? So that we have to be clear about it. And as just two nice open free and open source data management softwares. One is OpenClinica and the other is EdCap. It is a web-based across for ADC, and it has all the compliance. It's being used by many countries, and what is the basis, everything is there in it. And EdCap is another open source free database which can be used. It's developed in Vanderbilt. Although it is free, you have to get the license. Your institute has to write and complete it, get the license, and then you will use it. Okay. And again, the compliance is there. HIPAA as well as 21 CFR compliance is there, and it's based on PhD, and you can have programming done in that. And so many countries are using, and you see so many journals and cited like that. We have been extensively using EdCap in our organization. Almost or most of the trials are now running on EdCap, and we have used EdCap to do trial data monitoring also. And then this is how we develop for any trial. We have kind of instruments like patient information, randomization, follow-up details, toxicity. You even have the QA instruments built in. You don't have to type each and every question. It just can be kind of invoked in your EdCap. You start clicking the responses. So it will be very easy to use for your QA data. And we're using it for multicentric studies. We have a study in radiation oncology that PMC Kolkata is on site and Apollo is at the site. We have shared the data dictionary to PMC Kolkata, and they're able to easily enter the data the way we are entering. So multicentric studies is very useful. Best part of it is you have user rights. You can define the role, who will enter, who will add or delete the record, and who has the export option. Everything you can define. Excel doesn't have. You just click, send a mail attaching an Excel file, it will go to many people, and then everybody starts entering the way they want, right? That is a main mistake. So that is there with the EdCap. I just want to, but whatever you see, but at the end of the day, you use an Excel, right? So much we talk, so much we are aware of it, but how we kind of minimize certain things in your Excel. This is a kind of sample data from our hospital we have taken. So you see here, I marked the first two columns, and if you see here, this is how we enter. This looks at least neat, although it has some errors, right? At least you can see that in Excel, you have to enter each patient data in one row. That is the main. Columns are variables, rows are for patients, right? So see here, it has been nicely entered. But what you see here is there is a data about the date 12/1/2010 and 1 December 2010. You see the date has been entered, right? So formats are different in your dates. So if you take this data to SQLs on any this thing, you will land up in problem. I'll tell you. 1st December and 12th January, how will you're going to kind of see a difference of nearly a year, right? Your data can get going this year, that way. Excel to SPSS, when you kind of export the data, be careful about the dates. Unless you have a uniform this thing, your dates has to be rechecked. But for how many patients you're going to check? 6th July and 7th June will remain same there, when you take it to SPSS. We ignore, otherwise it's not looking 6, 7 and 7, 6 looks, valid for us, but we don't know how it gets this thing. This problem very often you will face. So what I do is I enter the data in dot 6.06.07, that format. For me, when I exported the data in SPSS, I got the same data. Especially when you have your, randomized studies, your, data randomization and your data last follow-up of this thing, your duration gets affected if you don't use a proper date format. And if you see here, we have the habit of putting all the numeric data that's not known NA. You see LDH. You get the values as well as NA. This is how we kind of do it in Excel, right? So, and when we take it to SPSS, I'll show you how it appears, right? So this is all done. And also what we do is, I'll show you the next thing. Okay, so Excel spreadsheet has advantages. It's simple, it's easy to use. It can be exported to any statistical software, all that as well. You can have large number of rows and columns, all that is possible, 66,000 rows and some, I don't know how many columns are there. And the problem is data can be changed without any help. Anybody can change. So data can have different formats. I get data, today there will be one data, same data will come, it will be different. The next day there will be a different data. So it is going to be very difficult when there is a change. Data for same patient might be entered several times. And repeat measurement of longitudinal data cannot be handled so easily. Suppose you have a QL of 30 questions and you kind of collect it for say 10 follow-ups. It's going to take you to the columns, it's going to be very difficult for you to enter and read the score and see the data. So that is the problem of Excel. So from Excel, when we move on to SPSS, nowadays people manage the data in SPSS, enter the data in SPSS. So SPSS has been used as data entry software nowadays. So what we do is we kind of open the Excel file in SPSS this thing. We have an option of opening different types of data. We use the Excel this thing to open. This is how it looks now from Excel to SPSS. What you see here is like the same. You have the ID, you have this thing. It's a kind of multicentric data. Okay, this is how it will look. Now, it will have two screens in SPSS. This is a data view, okay, and this is a variable view. Variable view will tell you what all variables, what type of variable, and what are the values of each variable. You can define that. If you want to define it in this thing, you can define them in that. So all this can be done. See, you have to remember when you're writing the name or the variable name, it has some limitations. You can't use space, you can't use a dot, you can't use comma, all that the way you write type in Excel. So whenever you export the data where you have defined in that way, if it doesn't understand, it will just tell you BAR0024. You will not know what it is. So if you want, you can kind of write it in a simple way in your Excel sheet itself. Or when it comes here, you have a short way of writing the variable. You want to give a detailed label, use a label column. So that you're clear, okay, what the variable means. And this is the data view, just a variable view, so you will know what type of variables you have in your data. And then you see, this is taken from a multicentric study. I had got it from to analyze, and this is 6,600 variables. I just took a snapshot, 3953 that I have shown. I have used 6,600 variables in SPSS to analyze the data. Going back and forth, There is an option called utilities. You can make subsection of your data. Please use that. If you're working on QL alone, make a utility like QL and put all the QL things in that. It will be very easy for you to kind of work. You don't have to open the full database to search here and there, right? So the utility option can be very well used if you have a huge database. And I want to just show you more things. Like see, this is your CD 31, CD data, CD3 data. You see here how it has been entered. Because in Excel, that is how it is entered. Numeric, along with it, you have NAD. Okay? So it is like that. So when you open the data here, you will have still the data showing like this. So you will be happy from Excel to SPSS, the data has come. But then when you analyze the data, you cannot go beyond anything when you want to summarize this data. You have to make this numeric. When you're making it numeric, all the NADs will go off, right? Similarly, the way of, you in Excel in a hurry, you just type yeses like this, 5, in some places YES, some places small y, capital ES. So many ways of typing this thing. So be consistent in your yes, no, or typing in Excel. So it will be easy for us to recode. Now, if I have to recode this, I have to use a function, small y alone, code it as 1, capital Y as 1, YES in different formats as 1. It becomes very difficult when the data comes to us for 2D. And for you also it will be difficult. Then similarly, you see here, where it is pre-transplant. What they want to say is yes, no, if yes, what it is. So you can have it in 2 columns. Why you want to put everything in one? There is a series of no, and wherever there is yes, they are typed. This is a very clumsy way of handling the data. You just have it in 2 columns. Have one column is yes and no. The other column is yes, what you want to ask. So similarly, if you see their age and gender, 24/F or 24F. This is how you get. Why can't you think of splitting it? I know in a hurry you will enter the data like that, but please have a splitter form. Similarly, positive, negative, POS, P, positive, all things, combinations with C here. So please take care of it. Otherwise, we spend a lot of time coding this data in this. Okay? And just want to end up with the RedCap database which we have developed. We have developed this under the DBT project, like involving the multidisciplinary team. So we have surgeons, pathologists, radiation oncologists, medical oncologists, all coming from 4 different sites: breast, lung, and colorectal. And we have developed it from our center, and it has been used for collecting data from 11 centers. Okay? CMC Vellore has developed it for lymphoma, so we're using it, and we have developed this first experience for us to develop this database. And they will be collected as a registry data. So what we did is, it took us nearly 6 months to kind of find this. Okay, so we had sections like demographics. It looks so neat to enter. This is how on a web page it goes. We can start entering it. We have sections like history, take the history. We kind of take examinations, histopath data, and the treatment plan. What is planned and what is delivered. Different this thing. Every columns will have a connectivity test and matching logic. Everything will very good. Okay, and we have the follow-up data. We have the toxicity data. All this was collected, and this we are now going to monitor the 7 centers data. That is the next challenge for us. So what I would say is to end up with
automatically from a spreadsheet also.
I can export it in any Excel or SPSS or any format. And I don't have to report the variables. It comes in with the built-in syntax with the programming. So that is it. And it is security wise it's stored in our server, and it's very, very nicely in this data. And we have also given access control to put between the data. And some of the fields has to be verified by the investigator. Otherwise, we don't say what's. Especially the treatment plan, the investigator has to verify. Then only who is verifying the data, everything we have it free. So this hopefully will come out to be a good database for us. So that's all I want to say. And we have to end this talk.